Hello, my name is Professor Vyacheslav Dushankov, and I will be your instructor in this online class. That means we will interact mostly via internet, and my physical location actually doesn't matter. I may be in my office in the Bronx or far, far away. I still will be your instructor, and I look forward to seeing you in my class. Now I will demonstrate the sheep heart dissection. And we will do it in class with a fixed heart, but it's much better to do it with a freshly cut heart from the sheep. I will show you details that you might not see even on the heart in the classroom. Because the best thing is, of course, to have the fresh heart. I will do it old-fashioned way. We are in Tajikistan, so I'm not restricted of many rules. That's the heart of the sheep. And that's a very young sheep, only 6 months old. That's why the heart is relatively small. Our human heart is a little bit bigger, and the regular sheep heart will be also a little bit bigger. But for the young sheep, it's a normal heart. It's hanging in your body only on the blood vessels. There is no connections to the bone or everything else. When you look at it, you should very easily distinguish between the base, top of the heart, and the apex, the bottom of the heart. Now you have to figure out where the front of the heart and the back of the heart. It's very easy. If you look around the heart, you will find the anterior interventricular septum and groove. Groove is right here, and this groove is contain the blood vessels, arteries, and veins, and it's diagonal. So as soon as you see the diagonal groove, it's guaranteed the front of the heart. If you look at the back, you still have another groove, but it goes almost vertically. That's how easily you can figure out where the heart front and the heart back is. As soon as you've done it, then you can see basically the area of the left ventricle and the right ventricle. Arteria are on top of ventricle. They're a little bit covered by fat. A little bit of fat on the heart is absolutely normal. It's actually beneficial. As you recall, the heart is working very hard and should have at least some supply of additional energy. Blood vessels. Let's see what blood vessels we can find. Of course, the biggest blood vessel coming out of the heart is aorta. So let's look at the aorta. Here it is, aorta. Aorta is coming from the left ventricle, and as soon as it's getting out of the heart, it has several branches of arteries coming mostly to the upper part of your body. On the right side of the heart, you have veins. In this case, veins are right here. And one coming from the top is the superior vena cava. One coming from the back, right here, is the inferior vena cava. So that's the blood vessels. And we also have the groove coming around the heart, separating the atria from ventricular. I will cut the blood vessels a little bit close to the heart, so we can have the heart separated from major blood vessels. And this way it reminds much more the heart that you will be seeing in the classroom. I will go ahead and dissect the heart to show you what's inside. I will do it by separating the frontal panel basically separating black and right and front side of it. And to do that, you have to find auricula, those hanging parts of the atria on both sides of the heart, and cut through them to separate frontal and back side of the heart. Okay, now we have a beautiful cut, and even if you don't go back to the exterior view to figure out where the left hand side and the right side is, you still can easily figure out where the right and left side is by looking at the wall of the heart. Left side of the heart works much harder because it's a circulation all over your body and has a very thick walls. The right side have a very thin walls. Then you have the atria on top. You have atrioventricular valve, which separates atria from ventricular. On the right side, it's the tricuspid valve. On the left side, it's a bicuspid valve. What also you can see very easily in the right ventricular, this moderator band. Moderator band connecting parts of the right ventricular, and it serves for both to prevent overwhelming flow of blood into the right ventricular, and it also provides some electric signals for heart contraction. Left side, atrioventricular valve called bicuspid valve or the mitral valve. Both atrioventricular valves have these connections to the muscles, which are called chordata tendinea. They look very strong and they prevent valve from overflowing. Now let's try to find some other parts of the heart. And one of the excellent holes that you can find in the right atria is the opening of the vein, which collect all the blood from the heart and opening it back to the right atria. And that's basically all I wanted to show you on the heart with this thick demonstration, very small demonstration. And the good thing, it's not going to be wasted. We are going to cook it and to eat it tonight.